You're very welcome to this presentation. Self-raising. In this lesson, we are going to be considering two ways to model a curve rafter using a I section, just like this. Okay, this one. So I will show you the two ways to model this successfully, and after which we are going to check the structure for an error. So if there's an error, we will correct it, and then we will carry out the analysis and design of this all of this structure successfully, and as well we will proceed to design foundations of this structure successfully. So stay tuned, stay connected. Don't forget to like, don't forget to also subscribe to this channel if you want to get a notification each time we upload a useful content of this kind. So let us get started. So I will be getting rid of this one that I have models already, and so I will have to click right here and do a window to actually get all of that selected. Right click, delete options, and then yes option or okay option. So I will have this just like this. So for you to fix such a such a curve I-beam rafter, it is a I-beam rafter. All right, so there are two ways you can fix it. Just in one of my video on my channel, I've showed us how to actually fix that using the frame options, which is this option menu. I'm at the story 0, so I have to move the grid lines to story 3 so that all of this will be enabled just like this. Okay, so there are methods you can use using frame. Okay, but I want to be showing you the difference between using this method and this other method and the one that is preferable. So at first, they look at the frame. If you click on this frame options right there, and then you will have a frame members dialog just like this. Okay, so in this dialog we will have our sections. Okay, and then we are already having a high beam, okay, of a 305 by 165. So you click on that provision so you can change the particular sections to a smaller sections. Let's say we have a section of 152 by 98 by 60 right there. Okay, so I will get that selected right there. Okay, and then I'll click on the okay options just like this. Okay, so after having this done, for me to have a curve of this over here, what I need to do is I will come to we have insertion method right there, and then I will select the second method curve insertion. So once that is selected, the plane normal angle is going to be 90 degree, and then the apex distance, so this is the apex height of the curve beams rafter. All right, so I will get that to be 2500 just like this. So having this imputed successfully, I will proceed to pick the first point just like this. All right, then I will take my cursor to this other point to make sure I pick this other point on the stanchions right there. You can see just like this, and then I will have my cover beam rafter just like this. Okay, so I can now close this, and I can also adjust the apex distance depending on what I want. And then if for instance I want to be 3 meters, which is 3000 millimeters, I key in and then I select update, you see it being updated. Okay, so you can adjust this all right successfully. This is Protastructure 2022. Take note. All right, so having placed this right away, you can also come to the 3D options, and these 3D options will help you to actually be able to have a physical offset of plane and in plane. All right, outside the plane and in plane. All right, and so you can also have analytical offset of the I end and the J end. All right, so you can do that successfully. Maybe you want it to go down, you can also actually carry out that using this provision successfully. Okay, and also if you want to create a support for it, maybe you are having a cantilever of this kind, you can also create a support for it. All right, so you have to understand this frame member dialog successfully. And also if you want to apply a moment, you want to fix it at the columns point of support, you can also fix it right there. Okay, using this provision successfully. I haven't explained that successfully. Now that you have placed this, now you will have to copy this. You can copy this. I thought as much. Right click, and then I think you can see a copy options. Okay, I'm not seeing any copy options here for this. Okay, since there's no copy options right there, we could have copy and then populate it along these directions. So since there's no copy option, we click on this, right click and click on e property, and so we are going to be using this property to place this curve beam rafter on other provisions. So to populate it along the trusses just like this. Okay, so I will not place it throughout, but I will place just 3, so that I will show you something that you have to take note while you are working with this particular method of a curve beam. Okay, so having done this, the next thing you're supposed to do is to place a rafter on this. Okay, sorry, is to place a lines on this. Okay, so for you to place a plan on this rafter, that is where the issue are. All right, that is where the issue are. So if you use this method, you find it difficult to place a line on it. For instance, I click on the lines right there, and then I'm supposed to pick the first one and pick the last one. You see, it is not actually responding. It is not actually responding. Do you know the reason? The reason is because there is no break node point where the rafters can actually sit successfully. There is no break node point, so there is no way you can place rafter on this. So this is just the reason why this method is not always used for a normal roof rafter successfully, just like this. But you can also place maybe you want to place or other things like braces on this is possible. For instance, if I click on this frame again, and then I will come to these provisions, and then I can navigate to this circular hollow sections right there. So I may use this one. Okay, I click on the OK options, and then I will go back to these options. Okay, this option this time around, not curve. Okay, it's these options. Okay, so I will have to pick on the beams. Okay, that point that is snapped, and pick on the next point on the beam, and then you can be able to place something like this. Okay, this is the only thing you can be able to place on this on the beam successfully to connect them, and then you can be able to run analysis, and it will actually pass analysis. So you can do something like this. Okay, and this you may not necessarily use it to represent your rafter. Okay, the reason is because it is not sitting right on the polines, but you can't actually manage that, and you cannot distribute it as you want. Okay, you can see if you are heading around the beam, you can see some snap point. Those are the only points you can place this. Okay, any point that is being snapped, you can see. All right, these are the points you can place this successfully. Okay, so this is how to place a curve beam rafter. And also you can also use any hollow sections. You want to make a curve hollow sections, you can use this too. Okay, successfully. All right, so let's try the second method. So I will close this, and then I'll get rid of this by deleting it just like this. If you have any question, you can drop it at the comment sections. Okay, and if you want to really understand Protastructure from A to Z, steel and concrete, join our mentorship program that is ongoing. We are training a lot of persons. Okay, so don't be left out. And then it is a live streaming training, okay, that we are coming out live with you to explain to you, and you have a time to ask any question at all in Protastructure. Okay, and one of the benefits will help you to obtain this program, and then we will use it and then train you perfectly on the use of this program successfully. Let us make progress. So the second method is using the truss. Okay, using the truss. Now what you need to do is you click on the truss right there. So once you click on the truss, you pick the start point, okay, of the truss, which is on the, right on the stanchion right there, and then pick the end point of the truss. This will open a truss dialog for you, just like this. So once the truss dialog is open, what you need to do, you have to navigate to this type of truss, okay, and select it. All right. Having selected this pattern of trust, what you just have to do is you have to navigate to the members and select the I sections that you wanted to use. If you click in these provisions, it will take you to the street trust dialog right there. So with this U beam, which is universal beam, you cannot select any of it that you intended using for the steel rafter, I-beam rafter. Okay, select that. Okay, and then select again to okay that. So at this point you can get back to the general, and then over here I see the Apex IT 2500. We may leave this at default. All right, Now, what you need to also take notice of is the panels of this. We have 1, 2, 3, 4, 5, and 6 panels, okay, right there in this truss. And so you have to make sure that you know the spacing of your polines, okay. The spacing of your polines, you have to define it here, because once you modify the truss, there's no way you can actually define the spacing of your poline, all right. And so for you to define the spacing of a poline, let's say I wanted my polines to be less than, I wanted my poline spacing to be less than, let's say 900 millimeters, okay. So I will come to this provision where I have numbers of spans, okay. I will increase the numbers of spans for this, for the 6 numbers of span. See the span length here, which is the spacing between the poline. It is 2666.67 millimeters, all right. So I will increase this to 18 right there. So if I increase it to 18 and click in this provision, you see it has changed to 888.89. I don't want it to be less than 900 millimeters, so I will now key in 17 of that spacing right there. So I'm now having 941.18 millimeter right there. So I'm okay with this, all right. So these are the spacing of my polines, all right, on the I section beam rafter, all right. So now the next thing you have to do, you navigate down up there, you see the truss support placement is top, so you must make sure it is top, all right. For all of these other ones, I'm not so concerned about it, all right. I'm not so concerned about the left vertical offset. I'm not concerned about the right vertical and the rest of that, okay. So if I come down, you can see also top and bottom chord, top chord left extensions, and as well right extensions. I'm not also concerned about that. You can see delete first and last verticals, okay. First and last vertical, delete it. We don't have need for that, but we get rid of all of this because we are going to be modifying this truss. So after we must have gotten all of this and we are okay with our spacing and the number of panels that the truss have actually we created, okay, you have to go to user defined truss. Click on this user defined truss. So once you click on the user defined truss, you will have your choice just in this format, okay. So what you just need to do, click right here once, and then you do a window. Please, you have to bring your hand down. It's actually taking the top chord of the truss. I wouldn't want it to touch the top chord, okay. So I'll click right there, all right. So I can be able to actually select to this extent all of the vertical, the diagonal, and as well as the bottom chord. I don't need it, okay. So after getting all of this selected, I will press I want to get my keyboard. I'm supposed to click press delete on the keyboard to delete all of that, okay. So I will be using my on-screen keyboard, so I will activate my on-screen keyboard just like this, all right. Once I get my on-screen keyboard activated, I click on delete right there to get rid of all of that. So remaining this one, I will zoom it closely, select that this is a vertical, okay. I'll select that and click on delete right there to get rid of this vertical. So now this is my I-beam, my curve I-beam rafter, just like this, okay. So I will minimize that and click on the OK options. So once I click on the OK options, you can see what I'm having right there. So this is the I-beam here that I have, okay, just like this, all right. So if I want to continue to place this I-beam, I can just continue to place it just like this, okay. Or if I deselect it, the first method, if you deselect it to copy is an issue, but this one, if you select it right there, if you check over here, you can see copy options. And also if you right click, all right, in the drop down menu, you can still see a copy option, which is this option. So we'll be using this copy right away. So I will select it right there, pick the first point, and then copy it to the second point, and then to the third point, and then to the fourth point, all right. And then I will make sure all of the columns as this cover beam rafter, just like this, all right. So after having this placed successfully just like this, the next thing is to now apply the poline. So select the poline right there, pick the first beam and the last one, okay. And then you have the polines, you know, dialog coming up just like this. You carry out some settings, and then the spacings here at fix is 1 meter, okay. So you can adjust this depending, and as well as the cantilever, you can also adjust it. But for the sake of this lesson, and then the gap between the polines, okay, is 20. You can see you have a gap between this and this gap, okay. You see here that is the 20, all right. So then the profile of the polines, okay, is also okay by me. So I'll be going by this. Click on the OK options to place my roof polines just like this, okay. All right, so don't forget to subscribe, all right. Let us make progress. So after which I'll be adding a clouding, and then I'll select this right away, and then my clouding dialog will come. I'll click on the OK options, and then I will have this just like this. Okay, so we have covered the first sections of these presentations, all right, just like this. So the second sections is the analysis and design. So I will be navigating to the analysis tab. Before then, we have to save the project. Click on the save options to save this project successfully. So I will be navigating to the analysis, and then I will navigate to building analysis, all right, and then I'll go straight to the analysis options, and then I will check this building model if everything is good. All right, so it is going to carry out some check, and if there's any modeling error on the model, it's going to show us here, and then we resolve that error. But fortunately we have no error. Okay, the number of errors is 0, so at this time we are good to carry out the analysis. So I click on the building analysis right there. So once I click on the building analysis, it is going to bring up some analytical options, okay, telling me to select which of the members to actually carry out. Okay, so you can see Butch design options. Okay, so this Butch design options, I only select team member design check. So for the concrete columns and as well as the reinforced concrete beams, okay, I will do that using the Butch mode, all right, successfully. So after which I'll click on building analysis. So I will have to give the program some seconds to carry out the analysis, and then design the steel members, but it's going to only analyze the steel reinforced concrete columns and beams. It's not going to design it for us. We will design it using the Butch mode, but for the steel member, it is going to analyze and design. Okay, so let's give the program some seconds. So now the analysis is done successfully, just like this. So you can see the relative draft satisfies the limits successfully in both direction 1 and direction 2 successfully. All right, so the truth about this analysis I did is this, that the analysis actually takes some time. Okay, so if you check over here, you see building analysis completed successfully, and in this analysis I doesn't have any error. There is no error of node displacement, there is no error of sparse over. This analysis was very smooth, although it takes quite some time. So after which you click on the OK option. So having clicked on the OK options, you will now have to see this place check, meaning analysis has been done on this structure successfully. I click on the close options right away, and then after which you will also see building analysis tab right there, icon is being checked, okay, green, meaning the analysis has been done on this structure. So if we now have to check the steel members to actually see if they have passed or they have failed design successfully. So I will zoom closely to the curve I-beam rafter, and then I will select that. Right, so after getting that selected, I just right click and then steel member design, I'll click right there. So once I click on it, give the program some seconds to bring out the design dialog just like this. Okay, so you can see on this design dialog over here we have the sections. Okay, we have the members right there. Okay, so this curve beam consists of various members, okay, split into fragments. Okay, so you can see it over here, and the material sections using the smallest sections strength. Okay, the smallest strength, still strength right there. Okay, so over here you can see the slenderness ratios. All right, the highest slenderness ratios we have here is 42 less than 200. Okay, so if this is 47 less than 200, the highest slenderness ratio, and if you select this, you can see where the highest slenderness ratio for, okay, at the support. All right, so if the 47 is higher than 200, okay, it's higher than 200, these members, this particular one may be failing. Okay, so also over here you can see is this one that has the highest slenderness ratios, okay, also have the higher utilization ratio. Okay, it's 0.39. okay, all other ones are smaller, meaning there is much load over here. All right, so you can see the design statute over there or as passed. Okay, if you want to show the utilization ratio on the steel curve sections, you can just click on the show U ratio, and then you see all of the U ratio right there. You can see this one 0.389 is found here, 0.389 9, okay, approximately. This is presented in 2 decimal places. All right, so you're having it just like that. Okay, so the same thing applicable to every other provision. So this has passed design successfully. I click on the OK options. I want to print a report. In this respect, you can just click on the report right there. If maybe it is failing and you want to actually make sure that you make it past the design, you can change the section using these provisions. Okay, so now you see the review ratio is quite far less than 1. You can change the sections to the smaller sections and see the reactions of the U ratio. Okay, so when the U ratio is higher than 1, it will actually fail. So if you come to this provision, click on the change sections right there, and then this will take you to the trust sections, trustee sections dialog. And then if you click here, there are other smaller sections right there, like 152, like 127. So if you maybe choose the smallest section, let's see what happens. Click on the select options and then OK options. You can't notice that it is going to redesign, and then you see the U ratio over here, which that was 0.38, sorry, 0.39 approximately, is now 0.72. okay, and it has also passed the design, and the year has increased to 61, which is the slenderness ratios. Okay, KL over R. Okay, it has increased to 61. Originally it was 47. All right, so and this has also passed design. This simply means you can also use these sections for this design successfully. Okay, so this is how you can also select your design and carry out your optimization successfully, and carry out your optimization successfully. So you click on the OK options and to get that done. So if you check here, these sections is now the smallest sections. Okay, the small sections compared to the every other sections you have in the model successfully. All right, so coming back to the 14s, sorry, for the reinforced concrete columns, you can now select on this, and then we have it at the story one, so you have to navigate to that story one. All right, and then you select the column, right click, and then if you click on this RC columns slash wall design, you will have a dialog, and then you notice in the dialog that all of the columns have not been designed because we did not ask the program to design it, just like this. So we have to design it using this bash mode. Just click on that and then select all bars and then click on calculate. So this will calculate it in just a few seconds, and then calculation will be completed, and then all the columns will now be assigned reinforcement that suit it. Click on close options to have everything done just like this. Okay, so you can see everything has been designed, and then the reinforcement steel bars has been assigned to the column successfully. Close this right there. So the same thing applicable to the beams. Okay, the same thing applicable to the beams successfully. So now we want to design the foundations. Okay, for the foundations you have to navigate to the foundation level, okay, which is the story 0, and then you right click, go to the plan view of that story 0. And so in this foundation design, we'll be considering it group foundations, part footings foundation design. So we are going to design it line by line, like this 6 footings. We are going to design it at once. So for us to do that, we will have to highlight all of these foot. Sorry, we can highlight it this way. Okay, like this. Okay, getting it highlighted like this, you can just click on this insert part footing, or you right click and then select the option insert part footings right there, and then a dialog is going to come up. Once the dialog comes up, the program is going to carry out the design of the footing successfully, and we are going to be designing this so that all of these columns are going to be carrying the same footing. So for us to do that, we have to activate what we call, I will first select redesign all options. Okay, then I will pick the first reinforced concrete columns, or the control key, sorry, the shift key, select the last one, and then you select group selected. Okay, this one, group selected. So once you group all of this, you can see the numbers of the columns 1C, 19, 20, 30, all of them has been grouped together just like this. After we must have done this, what we now do is we will now come to design all. You click these options, design all. So this is going to design and assign the same footing size to both LS and LY, okay, of the footings successfully. So you just have to give the program some seconds to carry out this design successfully. So now design is done. So what are these footings? 1.8 by 1.8 by 2.6. All right, that is quite very large footings, and then the depth of the footings is 400 right there. As you can see. All right, so that is the one of the disadvantage of designing footings when it is being combined, because you may try to manipulate these sizes by, let's say, you can increase this to meters, and then we try to reduce this, reduce it, and then you have to be checking, okay, sometime. Okay, so 2 meter by 2 meter has passed, because I wanted actually square footings. So after checking all of this like this, you can see it has fed there. Okay, so you have to now start increasing and then start to check this. All right, check this just like this, keep checking this, and then let's see, it is still failing, so we keep on checking. All right, just like this, it is still failing. You check that, so this we actually key sometime. All right, checking it to make sure. You see, now it has passed. This is 2.5 by 2.4. Let me reduce this and check that 2.4 by 2.4 has actually passed. Okay, so 2.4 by 2.4 has passed as the 14th. Let's check 2.3 by 2.3, 2.3 by 2.3 failed. Okay, 2.4 by 2.4 right there, okay, has passed the design. Let's see. All right, so we go by the 2.4. So this is how you actually change your footing to square footings when it comes to grouping. Okay, so I believe you have learned 1 or 2 things in these presentations. If you want to enroll in our mentorship program, I promised you that you are going to benefit very well in the program successfully. So we'll be clicking on the OK options, get to accept that, and then the footings will be instructed successfully just like this. So the same method you are going to use to apply it and make sure you insert all of your footings of your project successfully. I'll fix the rest of the part footings just like this successfully. You can see they are all grouped, okay, just like this one. Okay, and so I want to navigate to the 3D right there, so I will go through that process, and then here is our structure model in 3D. Okay, so this brings us to the end of these presentations for now, to be continued in the next presentation. And so don't forget to like and subscribe to the channel Soft Reason for more advanced lecture of this kind. And also, if you want to join our mentorship program and advanced training in Protastructure, Tekla structure, robot structure, and as well Revit structure, you can contact us through the link in the description of the video. Have a nice day and stay safe. Bye for now.